So first of all, I would like to thank the organization committee for inviting me to give this speech. It is a pleasure for me to be here. And today I'm going to talk to you about how we can integrate different methodologies and technologies for education and training at different levels. So starting from education for our university students up to training in company, to operator working in company, top managers and directors. But first of all, let me give you a brief outline of my presentation. We will see how we can integrate different methodologies and technologies that are mainly based on modeling and simulation for education and training. So we will go through from the simulation origins. We will see which will be the future roadmaps for simulation solution, and the way will be toward the use of serious game and Industry 4.0 concept. And this will be the first part of my presentation, some general concept about modeling and simulation for education and training. In the second part of my presentation, I will provide you with some examples, some simulation solution that we have developed in our lab to show you the functionalities of this simulation solution and the potential of this simulation solution in order to carry out education and training in different sectors. So we will see some example in industry, we will see some example in the maritime domain, training in critical infrastructure, maintenance and security in industry, just to give you an overview about how this simulation solution can be applied in a transversal way to different application domains. I will escape the slide about who we are and where we are, even because this afternoon there will be another panel in which I will say something more about who we are and where we are. By the way, we are located in the very south part of Italy, where others usually go on holidays. So you can imagine that it's quite difficult for us to work every morning. But jokes apart, let's see something about how we can integrate different methodologies and technologies for education and training. So the main idea is to use modeling and simulation jointly with other methodologies. We are talking about virtual environment, we are talking about augmented reality, we are talking about mobile technologies, about advanced visualization systems, such as, for instance, head-mounted display. We are talking about personal assistants and intelligence agents. Can we put together these methodologies and technology in order to address education and training problem, as I was mentioning before, at different level? For education, for our university students, maybe replacing even sometimes traditional exercise in classroom, to training of people working in company. As I was mentioning before, there are possible uses of modeling and simulation related to education and training in different sectors: industry, logistics, supply chains, and we will see later in the presentation some real application example. But first of all, we should ask why modeling and simulation. Every day we deal with very complex system. Let's consider, for instance, a manufacturing system. In a manufacturing system, you have multiple operators, multiple machines, multiple stochastic variables evolving and interacting at the same time. So this is for sure a system with a complex behavior. But even if we change application domain, let's consider the logistic domain. Let's consider, for instance, a marine port, a container terminal. In a container terminal, you have multiple ship arrival and departure. You have multiple ongoing operation, multiple container handling equipment working at the same time. Also in this case, this system show complex behavior. But again, if we change and we consider the healthcare sector, yesterday we were listening to a very nice presentation about simulation in healthcare, and even if you consider an hospital is even more complex because, for instance, you have to take care of patient life, you have therapists, you have scheduling and allocation problems, and so on. So all these systems are not linear systems where you cannot do simplification assumption and where you need something to recreate the complexity of this system. So we need simulation to recreate the complexity of this system. But this requires for sure more effort. Above all, modeling effort. It's not so easy to develop a simulation model, even because at the end of the day, you have to carry out verification, validation, and accreditation. So you have to be sure that your simulation model is able to recreate the real system with satisfactory accuracy. But in the end, if you have a simulation model ready to be used, you can use your simulation model to support decision-making from one side and from the other side for education and training. Today, we are not focused on decision-making. We will focus on education and training, and we will see how we can use simulation model for education and training. And above all, you have tried to develop simulation models that are reusable, so in the future, you can reduce your modeling effort. Well, but we are talking about simulation. Let's say something about simulation origins. Simulation origins can be dated back to the 50s, when simulation was firstly used in defense and industry. In defense for engineering, decision support, interoperability and training, simulation-based acquisition. From the other side, in industry, it was used mainly for manufacturing, process optimization, operation management, and decision support. But if I ask you, are we sure about simulation origins, that they can be dated back to the 50s? Actually, to be honest, we have to go back to the Roman Empire if we would like to talk about simulation origins. Maybe you know the concept of naumachia. Romans were used to fill the Colosseum with water and to put ships within water within the Colosseum in order to recreate their most famous battleship. This was, by the way, live simulation. It was done for entertainment purposes, but was live simulation. And the concept is the same that we use today. We are used to train people with live simulation as well. Let's consider, for instance, the case of emergency management in case of natural disaster, earthquake, tsunami, or disaster in industrial plants, as we usually see along the years. What we do is also live simulation, as Roman Empire was done more than 2,000 years ago. But if we think a little bit more about simulation, we can easily understand that we can use simulation not only for decision-making and education and training. We can use simulation along the entire life cycle of product and process development. So we can use simulation for engineering, we can use simulation for virtual manufacturing, we can use simulation for virtual testing, for training, but even to carry out distribution and logistics and cost analysis. In the end, simulation can be profitably used to conceive, design, build, test, train along the entire life cycle of our products and process. So, from this point of view, which is the roadmap that we have to follow? First of all, we have to develop a new generation of simulation solution. This simulation solution should be able to recreate different training scenarios. So in the real system, we have a lot of variability. So we have to cope with this variability. We have to tackle this variability in our simulation model. We have to recreate this variability by creating different scenarios, training scenarios in our simulation model to let people improving their skills by using the simulation models. In order to do this, we have first of all to understand which are the requirements of our simulation solution to correctly address the need of the real-world system. So which are the questions that our simulation model should be able to answer. Once we know the requirements, we have to define some general architectures for our simulation model. And these architectures should foster in some way interoperability, because we may have different models working each other, that they have to talk each other, they have to interact each other. And this architecture must also foster reusability of our models. After that, we can start implementing our simulation model with the help of stakeholders that are interested. I'm talking not only about companies, but I'm talking also about research center and university, because as we will see later on, we can use this solution for education and for training as well. And in the end, once our simulation solutions are ready, we can use this simulation for education and training to replace traditional exercise. Traditional exercise, in most of the cases, are done in classroom or by using, as I was mentioning before, live simulation. But live simulation has very hard limitations. For instance, if you carry out live simulation for emergency management procedure, you need, for instance, the availability of all the people involved in the live simulation. With live simulation, usually you can run just one storyboard. You do not have dynamic evolution of the scenario. So to summarize, we can say that live simulation and traditional exercise has limitation in terms of long preparation, few exercise, few scenarios that you can run, and very limited collaboration and cooperation among all the people that you need to train. Vice versa, if you use simulation, you can carry out cooperative training, for instance, by letting people experience virtual environment, by using head-mounted display. You can immerse more people in the same virtual scenario, and these people can interact each other as they usually do in the real system. They can undertake intelligence evaluation, they can cooperate each other, they can experience multiple scenarios, as well as they can carry out cooperative training, so multiple people at the same time, and standalone training, just one person, and I will let computer playing the role of the other people by using, for instance, intelligence agents implemented as part of my simulation model. Well, we are moving, if this is the direction, we are moving toward simulation-based serious game, because our users, they have to play a game in order to improve their skills. But we are talking of serious game because we are training people, or we would like to educate our students, and so we can use this. We may have the opportunity to develop different type of serious game according to our need. And we are in line even with the concept of Industry 4.0. We are now living the fourth industrial revolution, and even in this case, there are different methodologies and technologies that should be used in the Industry 4.0. We can remember autonomous robots, we can remember Internet of Things, cybersecurity, cloud computing, but among others, there are also simulation and augmented reality. So we are moving in this direction. And I would like to stress once again the importance of creating different scenarios for training, because real-world systems are really variable. There is a lot of variability in real-world systems, so we should be able to let people experience as much as possible many training scenarios. And this is quite important, and it is required above all a strong modeling effort in terms of creating different training scenarios. Now, this was let me say, the first part of my presentation, and I gave you some, let's say, information about how we can use modeling and simulation jointly with other technology. Now I would like to go through some real application examples, some simulation solutions that we have developed in our lab at University of Calabria in different domains, because we work actually in different domains. We have this simulation lab, and we work mainly in industry, logistics, defense, and more recently even in the cultural heritage area. Even because you can easily imagine that this solution can be used in industry, but even in a museum in order to support advanced fruition of cultural heritage. This solution can be applied in a transversal way. The first example, for each example, I have also prepared a video, so there are no theoretical concepts. We will look at the video and we will see the functionality and the potential of this solution. The first example is training in industry, in particular training for people that take care of emergency management in case of disaster. In the last year, there were a lot of disasters in different plants worldwide. As far as this simulator is concerned, we have two main versions of this simulator. The first one is used to train the external emergency coordinator. So let's suppose, for instance, the firefighter responsible or the civil protection responsible. So the person that is in charge of carry out emergency management. The second version is used to train the company internal emergency coordinator, so the people that work within the company and they have to support the emergency management. In each version, we have two interoperable simulators that are able to talk each other in order to carry out strategic level, the person that will take care of the emergency management, and operative training, because in many cases, people, if there is a disaster, a fire, people are scared and maybe they are not able to do very simple operations, so we need to carry out operative training. But let's see the video. This video, by the way, has been recorded during a demonstration that we did in Eni. Eni is one of the Italian major stakeholders in the field of oil and gas. And we did this presentation, this demonstration, by using our spin-off company. We have a company from our university that we use to present our research ideas on the market. This is the main screen of the simulator, as you can see. First of all, you can define your real scenario. You can insert information about the plant name, the city where the plant is located, the region where the plant is located. For instance, here in this example, there is a plant from Eni that is located in the Milan area in the north part of Italy. So you can define the latitude and the longitude of the plant. You can define the plant area in terms of square meters. So just by changing these parameters, you can create really a huge number of scenarios. And after that, you are required to put information about all the entities that are involved in case of disaster. For instance, how many fire stations there are and their equipment and resource, traffic bureau settings in terms of number of station, position, available resources, local military forces that can help in case of disaster management, or information about the civil protection, position, available resource, and information about hospitals. So at this stage, we are just creating the simulation scenario. And if we change all these variables, can you imagine how many scenarios we can create? Then we have to define which type of disaster. Let's suppose that we consider a fire. We have to insert information about the disaster gravity. We need to put information about the position of the fire and about the initial dimension of the fire that could be very large, for instance, or very small. In this example, in this simulation, it will be 10,000 square meters, so pretty large fire. We have to set up weather condition, because can you imagine if the day is windy and the wind will affect how the fire will spread in the plant area? So we have to define if day or night, cloudy, windy, rain, wind direction, wind intensity, and so on. And we are still defining our scenario, even in terms of people involved in the number of injured people and people involved in the disaster. And by the way, as you will see in a few seconds, even in terms of initial triage, so how many black code do we have? Hopefully no one. How many red code, how many yellow code, how many green code, how many white code. So in the end, we set up our scenario, and before starting the simulation, we have to define the user, who is going to play this game, who is going to train. Let's suppose there will be a name of the people that will be trained, and we can also set a difficulty level for this training session. That could be easy, medium, or hard. And we can decide the role. Let's suppose that the role is the firefighter responsible, that is in charge of the emergency management. Now we can start the simulation. Now we start the simulation. Let's suppose that I am the person that is going to take care of the emergency management. Once I will arrive on site, I am the firefighter responsible. I will receive some information on the disaster. I will receive information on the plant. I will receive information on the weather condition. I will receive information on the external resources that are available, firefighters, ambulances, civil protection, local military forces. So I receive a report with all the information that will help me in taking the decision. For instance, the number of people that are currently involved in the disaster. So once I receive all this information, I can start the simulation. And we have a control panel with different information. For instance, in this red graph, you can see the fire that is growing up. We have to do something to extinguish the fire, to solve this problem. And we can decide, for instance, how many firefighter trucks we are going to send, how many ambulances we are going to send, how many helicopters we are going to send. Obviously, if we send all the resources we have available, perhaps we will be able to solve the problem. But vice versa, if we send few resources, perhaps we will not solve the emergency. Therefore, we have to find the right trade-off between the number of resources we send and the number of resources that we keep, because there will be also other emergencies in other places. And you can see that you have different commands in order to control the simulation, and you can see what's going on in terms of injured people in the safety zone, person or injured people that have been moved to the hospital, as well as you can see that the fire is going down because firefighters, they start to act. You can monitor the utilization level of the resource involved. So by using this type of approach, you can decide how you can manage your resources. And by the way, this is strategic training. So the person that is going to take decision to carry out emergency management. You can have another person involved in the training session that use an head-mounted display and is experiencing the virtual environment. The people using the head-mounted display, you can see in the screen what he is currently seeing. So he's able to see the virtual environment, he is fully immersed in the virtual environment, he can interact with the virtual environment, even doing some very simple operations, such as, for instance, detach an electrical system, or giving the alarm, or giving the evacuation order, because many times when people are scared, they are not able to do very simple things, such as, let's call the firefighters, for instance. So this is one of the solutions that we have developed. Let's go ahead. And just few words, what's in the back of this solution? What is needed to develop this solution? Obviously, we need conceptual model to recreate all the emergency procedure. We need mathematical models for the fire dispersion and weather condition. We need physical and mathematical models for all the entities involved in the simulation, including, for instance, trucks, ambulances, helicopters, and so on. And we need a scenario generator, so something that is able to create different scenarios, so people do not have to play always the same scenario. And this is the virtual environment as it appears when you use the head-mounted display. This is a top from the view of the scene, and these are some people doing training session in a cooperative way. So you have more than one person immersed in the virtual environment. And at the end of the simulation, you get the results in terms of how many people you were able to save, if you have saved the system in your plant, and so on. So you receive a lot of information in terms of results, and you can see if you are able to improve your skill or not, and you have to repeat training session. Now let's change domain. I will go quickly, but we will change every time domain to see how we can apply in a transversal way this simulation solution. Let's move to the maritime domain. You should remember in 2013 the terrible accident in the port of Genoa in Italy, where the container ship Jolly Nero was hitting the control tower, and there were many people dead and injured people. So we have created a simulation system for training, for cooperative training of ship pilot, tugboat pilot, and port traffic controller. So let's see and this system, by the way, is currently installed in the port of Salerno in the south part of Italy, and is used for operators training. Let's see also in this case the video. So you can see that we have a replica of a real ship bridge with all the instrumentation that you usually find on board. There are some leverage for controlling the propeller pitch, or the main engine power, or the rudder wheel. So all the instrumentation that the pilot finds usually on board the ship. Side thruster, for instance, that you can control the ship motion, and so on. You have large screen on which you can see the virtual environment, so you ship while the ship is moving in the port area, as well as you have a control panel in which you can change the functionalities of the simulator. So now in a few seconds we will see a touch screen in which you can change, for instance, the different functionalities of the simulator. For instance, you can change the point of view to see, you can see the port from above, to see how your ship is moving in the port area. And you can control real-time the ship with hardware integration that, as you can see, it's similar to the hardware you find on board the ship. So you can look at from different point of view. For instance, this is the port of Salerno, by the way, and this is a container ship that is entering in the port of Salerno. This is the control tower on the ground, and so you can have the same virtual environment. You share the same virtual environment, and you see the ship moving even on the control tower. And we have the tugboat simulator. You know, the tugboat is the small ship that helps the large ship to perform movement and maneuvers within the port area. So you see, you can use the tugboat to push the ship, and all the three simulators, they share the same virtual environment, so you can carry out cooperative training among all the entities involved in the simulation. And this was developed in our lab. By the way, this was a very smart kid. He was the son of a pilot, and he was able to manage the simulator very well, just 8 years old. Let me go ahead very quickly. What's in the back of this solution? You have to recreate the 3D models of the ship, of the port, the virtual environment. There is the simulator of the radar system, of the AIS system. We have an interoperable architecture, so we have different simulators that are able to talk each other. And this simulator is based on the standard IEEE high-level architecture 1516 for distributed simulation. And these are the solutions, as I was mentioning before, currently installed in the port of Salerno. Some screenshot of this solution, the tugboat simulator and the control tower. Let's stay in the marine port. We were on the seaside. Let's move on the land side, and let's consider the case of training, cooperative training for RoRo operators. So RoRo operators are those operators that work in car terminals. So usually all the new cars are moved by one region to another, from one country to another, from one continent to another by using ship. Can you imagine that one single ship can bring up to 5,000, 6,000 new cars that are parked on board the ship very close each other? And if you make a damage to a new car, perhaps you have to pay for the entire value of the new car. So you need very well-trained operators that they have to drive the cars and carry out loading and unloading operation. And these drivers are usually, they receive help from parkers. Parkers are those people that provide indication about how to park a car in a ship. And let's see also in this case the video to see how the simulator works. If we can enlarge a little bit. So you can see the parker. This guy is using a virtual helmet and is providing indication to the car on board the ship about where they have to park the car. He can move around, he can see the situation, he can give indication to the drivers. And here you can see the drivers. There are 3 drivers, so we are training at the same time 4 people. There are 3 drivers that can move the car and can park the car according to the parker instruction. Even in this case, the hardware integration is very simple. We are using game controllers, so some pedals and wheels. According to the needs of the user, you can use something that is very simple, game controllers, or you can use something that is a real car cockpit, for instance, something that is more complex. So this is another example. Let me go a little bit ahead. This demonstration was done during a conference in Italy. What's in the back? There is also a lot of research and development in the back. For instance, for this simulator model, we have developed a glove for tracking the fingers movement, because the parker has to provide indication about stop the car, go ahead, go left, go right, and he usually uses the fingers, so you have to track the movement of the fingers. And we have developed our own glove in order to track the movement of the finger, as well as we have implemented collision, so you can see the damages in case of accident. Let's consider now the case of critical infrastructures. We have a lot of critical infrastructure. Let's think, for instance, to nuclear plants. Let's think, for instance, to power plants. Even, do you remember, it was a couple of years ago, the accident in the Gulf of Mexico about the Deep Horizon platform, offshore platform. In that case, this was for sure a critical infrastructure. So in that case, you need very well-trained people. We have developed this simulator for training on board offshore platform. So we can train people to execute maintenance and security operation on board critical infrastructure, and in particular on board offshore platforms. Let's see the video. So once again, this video has been recorded during the same demonstration in Eni, because they have a lot of offshore platforms, and therefore they are interested in using our, in adopting our solution for education and for training of their operators. So we will see how the simulation works. We can immerse multiple people in the virtual reality. So you can see there is this person that is immersed in the virtual environment. You can see in the screen what the person is seeing right now. He is on board the offshore platform, and he is going to do is physically, visually, and emotionally involved because it's fully immersed in the virtual environment. He can do some natural interactions, doing what he usually do in the real world system. For instance, now it is closing a valve, and so it is doing like this. His body is tracked, so he can move in the virtual environment as he does in the real environment. You can carry out cooperative training, so in this case there is an additional operator that is using another head-mounted display, and this controls the crane that you can see in the screen. There is this crane, and they are performing maintenance operations. So you can have multiple operators working on the same task. And by the way, the simulation is running on a mobile phone. And this is an additional issue, let the virtual world running on mobile phone. You can execute real operation that requires the same time in the simulated world and in the real world. You have the instructor workstation, so you can observe all the operation, and you can provide feedback to the people involved in the training session. You can set up the environmental condition, date, night, weather condition, wind, fog, rain, or whatever you need in the simulated scenario. You can learn. The main idea is that you can learn by doing with no additional cost, because if you perform something wrong in the virtual environment, nothing will happen, by the way. There will be no problem. Vice versa, if you make something wrong on board an offshore platform, then you may experience some serious problem, as it happened in the deep horizon in the Gulf of Mexico. And as I was mentioning before, you can run in this virtual world on mobile environment. So this is the main idea. You can have hardware integration, joystick, remote control, so real cockpit according to the user needs. Let me go a little bit ahead with the video. And what's in the back of this solution? There is a strong hardware integration, because, for instance, you have to integrate different head-mounted displays, such as the Vive, the Oculus, the Samsung Gear virtual reality. You have to run this virtual world on mobile phone, and this requires optimization in terms of graphical work, let me say. And this is the virtual environment as it appears when you use the head-mounted display. So you can live your training experience no matter where you are in the real world, because you are fully immersed in the virtual environment. And also in this case, you receive some results of the simulation in terms, for instance, of session time, exercise time, precision, number of movements, and so on. So you are able to see if you are improving or not your skill, and you have to carry out additional training. I will go now with the last example of my presentation. In this case, we will use mobile devices, augmented reality, and knowledge navigators to carry out maintenance and security in industry. So the main idea is that can we put together smartphones, mobile phones, augmented reality system, virtual reality, and knowledge navigator. Knowledge navigator, you have the knowledge navigator on your mobile phone. Siri, for instance, for my phone, is a knowledge navigator. You ask some question and it is able to answer. So we have developed our own knowledge navigators to support maintenance operation in industry. So while you are executing maintenance operation, you can ask information and say, where is the component that I have to replace? So who can replace the component? So how can I replace the component, and so on. Let's see very quickly the video. This is the last video, and then we are at the end of the presentation. I will go very quickly. So you can see, first of all, there are some settings about the personal assistant. You can decide the voice, you can decide the tone of the voice, you can decide some basic information about your personal assistant, then later it will be able to give you answer if you put if you ask a question. Let's see first of all how it works with with augmented reality. I will go a little bit ahead. Okay, in a few seconds. Okay, now you can see that on the desk will appear the machine. So we are using augmented reality. We can look at the machine from different point of view. We can understand the different components. We can go closer or far, as well as we can, for instance, access to the virtual 3D models of the machine in order to zoom in, zoom out, or to see how the machine is done, or to execute some maintenance operation. So, for instance, we can start some interactive procedure in order to replace some component. You can see that the application is now providing information about how to execute a specific maintenance operation. So you can even access, in the end, I will go a little bit ahead, by the way, just to summarize conclusion, the main idea is that we can put together different we can put together different methodologies and technologies in order to support training. I have to stress that the most important part is to create different scenarios, is to cope with the variability that is typical in real-world systems. We have to let our people experience as much as possible many training scenarios. And we can do this by reducing costs, by using simulation-based solution.
My question is, I mean, thank you for such an exciting and energetic presentation, and clearly the work's you have an enthusiastic team there, but who are your competitors here? Because clearly there is a commercial model behind all of this, and you are not owners of the hardware or the core technology. You're really the sort of go-between between the industry demand and essentially writing the code and facilitating and bringing together all of the technology for a solution, right? So I imagine there's potentially a number of commercial competitors that will enter this market or are already in this market.
Let me say something more about this, because this is a very important question. By the way, first of all, let me say that these are innovative solutions and ideas that come from research that we try to bring on the market. Yes, there are competitors, but as university and as researchers, we can put something more inside within our solution. So for instance, if you consider the ship motion at sea, you need researchers to apply the second law of Newton to a container ship that is that is in length is 300 meters. So what I'm trying to say is that, okay, there are competitors from a commercial point of view, but we are not selling normal products or services. We are developing something that is innovative and that is characterized by strong modeling effort and research, because we would like to recreate the real system. And in order to do this, in most of the cases, you need research and you need university. And indeed, the problem that we face every day is that it is really difficult for us to go on the market. That's the reasons we have created our spin-off company. Our university support us to bring our research ideas on the market by using a spin-off company, because people think that these are commercial solutions. These are not commercial solutions. First of all, these are research and innovation ideas that take the form of a product or solution, and you try to solve some specific problem in cooperation with, you provide these services to companies if you are able to do this.
Thank you for an exciting presentation. I'd like to know how available these simulation packages are for universities that are training in this field, and what would the cost implication be for a university that would like to engage in this sort of training?
It depends. What we usually do as university group and university research, we try to share our knowledge for free, above all when we talk with other universities. So we have a lot of cooperation. So for instance, with Professor Affenzeller, we always try to exchange for free, because it's important to share knowledge among universities. This is what we can do from our side. What you can do from your side, obviously, some of these solutions may require some licensed software costs, and so you have to pay something. But the knowledge is the most important part, even because when we talk about cost of software licenses, many times the software company, they provide for free the licenses to the university, because university use the licenses for research and development and not for commercial reasons. So if you want to start, you need knowledge for sure in the area of modeling and simulation. And as far as my group is concerned, if we could be of help, we can share our knowledge with big pleasure. And vice versa, you have to to start to develop something, and then you can use something in your own university. Instead of buying something that is ready, you start to develop something. For instance, in my own courses, I teach industrial plants, design and management. In my own courses, we have replaced the traditional exercise with the use of simulation models to explain how manufacturing system works and so on, because we feel that it's better for students, they can understand better how real system works.